Thank you, everyone. It's an honor to be here today. I am going to be presenting a presentation that was built by my colleague, Karen. And because I had to step in for her, I decided that I will give you not 10, but 11 things today that your data can do for you. This is going to be quite a fast-paced talk. You might not get all of the things as I go through them, but I have a bunch of resources. So if you want to see the slides for the talk, follow them as I go through them, or if you want to read about every single thing that I will share today, please feel free to scan the QR code, write down the address, or follow me on Twitter. I don't tweet that much, but I will feel much better about myself if you follow me after this talk. So please do that if you're on Twitter. If you're not, create a Twitter account and follow me. And with that said, let's get serious. 11 things that you didn't know your data could do for you. And after you hear these 11 things, you will want a data platform that can do them for you. By the way, I work at MongoDB, which is a database company, and we also have a data platform called MongoDB Atlas that allows you to deploy your database in the cloud and do all the things that I will show you today. First thing, your data will change. And as a developer, I don't really like that because when I work with a client, I used to do some freelancing projects and they would give me some requirements. I will go and define my data model. I will build my relationships. I will build my system, connect everything. And then they will come back and say, well, there's been a change. And now you have to go back and, break everything because I want the system to do things in a different way. So as developers, we don't really like change. But change is inevitable. And I don't think I need to translate this for this audience. But just in case, this very smart person said a couple centuries back, millennia back, actually, not centuries, that everything flows, everything changes, and it is inevitable to have change. And this is especially true when you're working with clients and when you're building software. So we just need to embrace the fact that our data model, our requirements are going to change. And there are some technologies that we can take advantage of to make this change less painful. One such model is the flexible data model. Now, if you're using a database that supports a flexible data model instead of rigid tables with rows and columns, you can have one such document, for instance, this is a JSON document, which describes a person. In this case, we have a person, we have their name, their date of birth, their address, and we have a new requirement that comes in and says your data object now should also support the telephone number for this person. So if we had this flexible data model, we could just go ahead and add a new field called phone, add the required information, and we can also take advantage of the schema versioning pattern and add this version field there. We can call it whatever we want. We can denote that this is version 2 of our model. And then later on in our application, we can read that from the database, read the version field, and handle or kind of remap the object to our application object to make sure we are using the right one. What is the benefit of that? Well, first of all, we don't need ORM mappings if we have flexible data model. Second, we don't need to run database migrations. Basically, we don't need to take down the whole database, get the whole table, add a new column, and fill in some random stuff for telephone number because we don't have the telephone numbers for the existing 1 million customers that we already have in the table. Then write that table back to the database and then bring the system up again. So this is the way to run a database migration. And if you have a flexible data model, you don't need to do that. You can just update the new documents that you write, or when you read a document, you can then update it, write it back with maybe the additional new field in the new schema. Something else that the flexible data model gives us is the ability to break down interdependencies between our data, which leads us to thing number 2. Data interrelates. There is no such thing as non-relational data. Non-relational data is data that doesn't have anything else in the world that it's connected to, and we don't, this is the data we don't care about. Data that we use in our systems, that we model our software after, has connections, has relations. So there is this term. How many people here have heard Nosql? All right, everyone, like forget this term, please. So Nosql was coined by some marketers, maybe a couple, 10, 12 years ago, to denote databases that were not using SQL, like the SQL language. And this is an incorrect term because nowadays these databases that are coined as NoSQL can actually very well use SQL or the SQL language for querying data. So this is not a very appropriate term, it's a marketing term. An even like worse term is non-relational. Now, there is no such thing as a non-relational data or a non-relational database. Like data in document databases has relationships. It's just, yeah, it's not non-relational, it's quite relational actually. A better term for these databases that are not using tables is non-tabular, because they're using different schema models, different data models to shape the data and persist it. Now there are 4 main types of non-tabular databases. We have document databases. The leading example is MongoDB. It's one of the first ones, and it's still the leading document database. We also have key value stores, and a very good example is Redis. A lot of people use Redis for cache. You can use it for other things as well, but it's a great example for a key value store. There are also white column databases or stores. Most popular white column database is Cassandra. And then there is this 4th type that is a little bit quirky, which uses graphs as a primary data structure for storing objects. And these are the appropriately named graph databases. Popular example is Neo4j. So today I'll be giving probably examples and saying things about non-tabular databases, primarily about document databases and primarily about MongoDB Atlas. But a lot of the abstract concepts can be applied to all sorts of databases and all sorts of data platforms, depending on what kind of features they have. So these are universal truths, but I will be showing them in the context of MongoDB Atlas. All right, now on to the data platform part of the talk. Your data should be able to drive diverse workloads. You have your transactional workload, which is the application that your users use. They buy things, they interact with it, they do like certain interactions, and this is your transactional workload. But you can also have analytics in your database. You can have full text search. You can have even time series collections like IoT sensors that send data somewhere in your database. These are all different types of workloads that you can drive successfully with the same data and through the same data platform. I'm going to show you a lot of examples using this application, Atlas Search Football. You might see this word there. So my coworker Karen, she built this application and she is based in the US, so they use this word for when they talk about football. I hope no one is offended when they see soccer. We know what we're talking about, like it's football. I hope you're all football fans here. Okay. Fair enough, fair enough. So this is the application that she has built. And it's an application that you can use, a web application, to build your dream team. So you have the different positions. You also have a text search over here that you can use to search for players using different search operators. So we can search, and we can also use faceted search, like more advanced search, to search for categories or for countries. We can have custom scoring and a bunch of other things. We can also have, we can add players to our team. And we can also have wildcard search and autocomplete search. So when I type now, yeah, you should be able to see autocomplete search. So you can see that this is a very simple application that drives two different workloads. We have the transactional workload, which is adding players to the team, taking them out of the team, and we also have this full text search workload. And we are using the same platform to build this application. By the way, I have a workshop tomorrow at 10 a.m. in MC2 where we will build the functionality for search, like all the different operators and all the different custom scoring and everything that you saw in this demo. So if you're interested, pop by tomorrow. All right, so drive different workloads. The next thing that we have is connect and combine. Now, in the ideal world, your data is all in one place, in one database. But in the real world, your data is spread out in 50 different places. A common use case that we have here is an e-commerce store that has different suppliers. And every single supplier uses different data formats. So you can just get the data from these suppliers and drop them in an S3 bucket somewhere in cold storage, and then try to combine them somehow to display them in your application. And you might have like different examples of that. You might have systems for analytics. You might have search systems if you're using Elastic or another search provider, SOAR. So it's usual to have data in different places. But how do we combine them together? I'll show you one technology that you can use. This is data federation. And the demo that I will show you is, again, in MongoDB Atlas. And it will allow you, this demo, to combine data from your operational database, so the players' data that we saw, with data coming from a third-party API, data coming from TikTok. In the end, we want to be able to search for a player, expand their details, get the data from our database, like their name, their team, their overall score. And we also want to be able, at the same time, with the same query, to get a video from TikTok that we can display and derive user engagement with it. And again, this is combining data from different sources. So let's build that. So here we have our database. These are the collections list. And you can see we have the football players. These are the different documents, the different entities in our database for the players. We want to combine that, again, with TikTok. So I'm going to go to Data Federation, and I will create a new virtual database. I will add a data source. The first data source is the collection from the database. And the second data source is an HTTPS endpoint, which will point to the TikTok API. Now, I can configure the virtual database and the virtual collection. I'll give them more proper names, like enriched player data. And I will drop these two as data sources. So we're going to have two different data sources for the same virtual collection. Now, this is like a real collection. We can just connect to it and start querying it as though it was a real collection. I will connect to it here using this GUI, this MongoDB Compass. And then I can just go and start querying the data. Now, when I query the data here, on the right, you don't see all the details, but the document that I get back has the enriched player data, so data from the database and data from TikTok. And when I combine this with the application, basically when I start querying the federated database in my application, you will see the effect. Do we have audio for that? I don't think we do, but that's fine.
All right, guys, Flint's challenge with the one and only
A little bit.
Let's go.
But yeah, you can see that we have this video coming from TikTok and then the player data. I have one more video, so if you turn it up, we will hear the TikTok. So we search for another player, and yeah, we get this effect. Yeah, thank you. All right, so this was a cool, neat feature, and it's nice to showcase federated data. But what federated data does is allow us to combine virtually, without moving data from different data sources. So data from our clusters, data from third-party API, data from S3 buckets, and even data coming from different databases. And we don't need to move that data, which is slow and expensive. We can just query it as though we were working with one single database. Thing number 5, our data should be able to drive application functionality. Now, a very common architecture that people can use is the event-driven architecture. In this example that I have for you, this demo, I will have someone sign up using the a sign-up form and click a sign-up button, and this will send an event to the backend, to the data platform. The data platform will run some custom serverless function that will try to create a new user, and if everything is valid with the user data, it will persist the user in the database, and this will be the sign-up logic for our application. Again, we're using the same football application, and first I will create the backend for that. So I will go to triggers, and I will add a new trigger. You see that we have 3 types of triggers: database, authentication, and scheduled, like cron jobs. We will use the authentication, as you may have guessed, and we will call this sign up new user. This will run when someone tries to create a new user. It will run when someone tries to sign up with email and password, and we will execute a serverless JavaScript function. This JavaScript function is like a Lambda function or a Google Cloud function. If you're familiar with this, it works using the same principles. So you don't pay anything for it. You pay when you use it, and there is like 1 million free executions, so you pay next to nothing. And then when we implement the client-side logic, I can go to sign up and enter details for the user. And when I click sign up, this will create a new event which will trigger the authentication logic, and it will create a new user. And it's simple. Like, you see this very simple application that we had. We could add layers and layers on top of it using all these things that our data can do. Right, thing number 6. Our application should be able to drive deeper user engagement. We saw that how easily we can engage users by embedding this very viral TikTok video. And actually, when our users start playing with the application, start interacting with it, they're also raising different engagements. So liking a player, or seeing more details about the player, or adding a product to a cart. These are all engagements that we can track, and we can use them to discover trends. If there was a football player that everyone in Greece suddenly started browsing about and liking, we should be able to identify that this is a trend, and then we can just show this player higher in the search results for everyone else in the region. And we can be able to catch these events, again, using the event-driven architecture, discover trends, and create more personalized and customized models for our users. There was this example that Karen gave me because she has been working in the gaming industry for like almost a decade, even more, I think. And they do A/B testing in gaming like super much. So if there is a level in the game that is hard for people have a high failure rate in it, they would create different types or different implementations of this level, like maybe with an easier monster to kill, or an item that can be dropped and they can, the players can collect, basically making the level slightly different and trying to improve it. And they will send out each of these versions to different sets of players and then use that data, analyze it, and pick the best improvement, the best implementation of level and distribute it for everyone else. So A/B testing is, again, can be used to drive personalized user engagement. Thing number 7, your data should be able to inspire you, and not just you, it should be able to inspire your UX people, your designers, to create better experiences for your users. And when your users start interacting with your application, they generate even more data. So you can as well use that data to analyze it and inform your business decisions. And this should be an ongoing, never-stopping process. Now, how do you drive business decisions? Through analytics. And now, traditionally, there's a very specific way to do analytics. Analytics are done separately from developing the product. They're done by specific teams, and these teams use their specific products like Tableau or Juniper Notebooks or even Excel or let's say BigQuery. They use these sort of tools. And on the other side, engineering teams, they live in a completely different environment. They store their operational transactional data in another database, which causes problems. First, it's slow, and it doesn't meet the needs for a very large set of applications nowadays. Simple example, if someone steals your credit card and they try to pay somewhere at the checkout counter, you would want that fraud to be detected like within seconds. You don't want it to be detected 2 hours from the purchase. So traditional analytics don't really work in that case because traditional analytics take a long time. And in order to do that, you need to be able to perform better, faster analytics or in-app analytics. If this is how traditionally things look like, we have these expensive and cost-effective ETLs that take a lot of time and money to implement and are hard to manage. To move data somewhere where people can analyze it, we actually want to bring the data analytics left to the application, to the database, and make it faster, basically, and less expensive. So what would that mean for our existing tools and our existing applications? First, for developers, it would mean that we need tools and APIs to build more sophisticated analytical queries. Then we also need tools and solutions with optimized storage and indexing. And for analysts, it means that they should have still access to raw unprocessed data, and they should be able to use their familiar tools like Tableau or SAS or all of these. And probably most importantly, running analytics should be isolated from the transactional workload, so it shouldn't affect the performance of the production application. So in general, we need a single unified platform that can serve different workloads and can serve also different teams. And there are various ways that platforms implement that. Just a couple of examples. In MongoDB, you can create a secondary node in your cluster that is reserved for analytical queries. So when you run your analytical queries, they're executed on that node and then don't affect the performance of the rest of the application. What else? Yeah, you can also use data federation and combine data from cold storage, your historical data and your operational data, and analyze that together. That provides you with better analytics. Thing number 9, just 3 more things, and you're free to go. Are you bored already? OK, I'm glad. I'm sorry if I was boring you. All right, so thing number 9. This is the most exciting thing, so it's a good moment to wake up. Your data and your systems should be able to grow as your demand grows. Let's say that we launch this football application during the World Cup, like 3 years from now or last year. Because people enjoy football all over the globe during the World Cup, our application will go viral. A lot of people will start using it. And people from different countries all over the globe will start using it. So how do we handle this global scale? And I can tell you that we have a bunch of customers that have tried to distribute their data across the globe, and they have failed, or it has been very hard for them to do it. And this feature that we will show you is really driven by that demand and that pain that we have seen in customers. I will show you how you can scale your database across global clusters and across global zones. All right, we have our familiar database with the players. We can go to configuration, and we can enable global cluster configuration. When we do that, we can select from 2 already existing configurations. You see the map with the zones that are enabled for distributing our data. And then we can start adding or moving clusters around. So right now, we can select this zone in Sydney, and we can move it to northern California. So we will have 2 zones in the US. And having multiple zones in these regions basically means that people in these regions will have the lowest latency when accessing data and when writing and reading data. But how do we know which data goes where? We can add something called sharding key. Sharding is the technique that MongoDB and other databases use when they distribute data, when they split data and distribute it across different zones and data centers. So we can add a sharding key, which tells which document should go where. So here, you can see that we have location, France. So this will go somewhere in Europe, and we have location California, so this will go somewhere in the US, whichever is closest. And then at the bottom, we also have location Deutschland or Germany, and this will certainly go to Germany, but there is a special case with German woes that we will talk about as well. I'll skip that. So we can enable also local reads in all zones. And what this does is it actually adds 1 secondary node from every zone into every other zone. So every zone can easily and quickly access data from every other zone. And I played this too quickly. So we enabled local reads, and there are laws in Germany which say that data for German customers should only stay in data centers in Germany. So you don't want to duplicate that data. You don't want it to be in California as well, because you'll be breaking German law and it won't be compliant. So we can go to the data center, the zone in Germany, and we can delete all the secondaries and make sure that this stays only in Germany. And after the World Cup is over, we don't want to be paying for all these clusters, so we can just go ahead and delete all of them. It's as simple as just clicking delete and saving the configuration. And that's how global clusters work. This is connecting to the database. But yeah, I think it's a very straightforward way to implement that compared to what people had to do before. Right, a couple more slides on this specific feature. Now, developers don't like sizing infrastructure, and most importantly, developers are not paid for that. They're paid to build features, ship them, and make things that help the business earn more money. So developers can spend their time doing better things like building software. And there are ways to alleviate that, and one of them is serverless. Now, serverless is a very loaded topic. I'm not going to talk too much about it. I have a lot of resources in the QR code that you scanned about serverless and serverless databases, but just shortly, serverless, the first benefit is that you don't need to provision infrastructure yourself. There's a platform that handles that for you. The second cool thing is that there is auto-scaling. So when the demand increases, the server the platform will automatically provision more servers to handle the incoming demand. And when the demand decreases, it will scale down. So it will remove all the unnecessary servers for you. And third, you're paying only for what you're using. And this can be a different thing depending on the platform that you use. If you are executing serverless functions, you are paying for the CPU and the time while the function is running. If you're using a serverless database, you are paying for the storage that it occupies and also the read and write operations that you execute on the database. But the common thing is that you are always paying for consumption. You're not paying a fixed price every month or every hour or, I don't know, every year. You're paying per consumption. There are serverless databases. We have them also in Atlas. A bunch of other databases have them too. But they're a little bit tricky to get right. So if you think that's something that you might want to leverage, come and talk to me after or read the resources. All right, thing number 10, go with the flow. So your data will have to go in different places. We have a bunch of examples for this. I'm going to give you just one of them. There is this thing called online archive that allows you to automatically archive historical data. So when you collect a bunch of historical data, like timestamps or just a lot of data that you don't need, you can start archiving it over to a colder storage. Colder storage makes sure that you are paying less than for your operational database, but it is slower to query. So you're making this trade-off, but because you don't expect to be accessing this historical data, it makes sense to move that to a colder storage. And online archive makes this very easy because you can set certain time to leave for all of your documents on selected collections and just move this historical data automatically and pay less. And the other benefit is that if you want, you can use data federation to query both the colder storage and the Atlas database. It will be slower, but you can do it. So it's queryable storage. And now you might understand why I needed 11 things here. So if you look closely, these are our players, and we have one player missing. Can someone guess who that is? Yeah, the goalkeeper is missing. So we need to be protecting our users as well. So smart, I'm so proud of that. I didn't even think of it myself, but yeah. All right, so protecting data, this has to do with compliance, security, and all the other things that you typically don't want to think about when you're working with data. But luckily, most modern databases have you covered. So you have TOS encryption while the data is moving through the network. You also have encryption at rest when the data is stored on the database servers. But there is a problem here because the data is decrypted when it hits the server memory. So this data is vulnerable, and this is the case, the default case in any database you might choose and might start using. And people just live with that. But there are a lot of companies that can't live with that because they have stronger security cases. We have a lot of banks using MongoDB, and obviously every bank uses some database. So for them, it's important to have a technology that can help them fix that. One of the things that you can do is use client-side field-level encryption. With client-side field-level encryption, you set a key in your client application. You select a few fields that you want to encrypt, like a personal identifier or something. And this gets encrypted. It goes through the network. It stays encrypted the whole journey. It goes in the database. It's encrypted there as well. And then it's a little bit slower to query it, but it stays encrypted. And this was like our solution 2 years ago. Last year's solution that is still in public preview, so it's not shipped yet, is this incredible technology that is really a groundbreaking thing that no one else does. So I encourage you to read about it if you're into cryptography or encryption. This Queryable encryption basically allows you to access your data while it's encrypted. So it never gets decrypted. It's decrypted only when you get it back on the client. So it's a really cool thing, and read about it. And it's in public preview, so if your company wants to try it, definitely contact us. So now we have our full team. And actually, what I wanted to show you with these things, with this talk, is that your data can be used in so many different ways, and you really shouldn't settle down for the minimum that your database can provide you, or your database 10 years ago could provide you. If you want to leverage all that, you can use a data platform, and you can just drive deeper engagements, analyze your data in better ways, and so on. So data has come a long way, and you can leverage a lot more than you are using today. One final plug, this is the workshop tomorrow. It's going to be just me, but Karen helped me build it, so she's there as well. So yeah, if you are coming tomorrow, please come. It's hands-on workshop, so you will need your laptop. And finally, the slides and the resources again, if you need them, please scan that. Thank you.